Candy. Here's what I want you to do. I want you, as quickly as possible, to tell me exactly how much and of what kind of candies I have in that picture. What we're going to be looking at today is called combining like terms. So what we want to do is we want to simplify an expression by combining like terms. If we look at these candies and we count them up, it would be easiest to present how many there are by looking at what type we have and how many we have of that type. For instance, I could count how many Twix bars are in there. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so I could say, oh hey, there are 9 Twix bars. And then I can count up how many Hershey bars there are. So 1, 2, 3, 4, it looks like of those. And so on and so forth. I could go through this whole process, and now I've made a list of 9 Twix bars, 4 Hershey bars, so on and so forth, to say exactly how much candy is in that. Now, interestingly enough, is what you don't automatically do on this. I don't go through and say, there's 1 bag of M&Ms, and 1 Twix, and another Twix, and another Hershey's, and another Hershey's, and another Twix. Nobody talks like that. Nobody does that. The reason being is it's really, really inefficient. It's hard to keep up with. What we naturally do is group them by what are the same, and then count how many of those are. We're going to do a very equivalent thing now, but for math. To back up and take a big picture look at this, however, what we are doing is called simplifying. When an expression has a variable in it, there is no way to find the number that the expression describes. In fact, you could argue that the expression describes an infinite number of numbers based on what the variable could possibly be. So if our expression, remember that doesn't contain an equal sign, if our expression contains a variable, we can't know what number that variable is. So what we do is we take the expression and we try and make it as easy to understand as possible. And this process is called simplifying or simplification. Just like we did with the candy, we're trying to present the information as quickly and easily as possible. One way that we can do this is by combining like terms. And this is exactly what we did with the candies. We combined all the Twix bars, we combined all the M&Ms, we combined all the Rolos. So when we do this with mathematical expressions, what we're looking for are combining all the terms that are similar. Remember, terms are pieces of the expression separated by plus or minus signs. So we can take all the constant terms, remember a constant term has no variable, and we can combine these terms. They're said to be like terms. They're all constant. We can add or subtract those together, and we can condense them down into just one number. Linear terms, remember that's a term that contains a variable, just one single variable and no exponent. Linear terms can be combined if they have the same variable. So to combine them, all we do is add or subtract their coefficients. Now I can say that at you all day long, but we're really not going to get a good picture of it until we go ahead and just try some. So I've got the expression, remember it's an expression, no equal sign, 3x plus 2 plus 5x. I will never, ever, ever be able to figure out what x is because this is an expression, not an equation. But what I can do is combine them all together. Just like I combined all my Twix bars in the candy example, here I can combine everything with an x. But notice that when a term has a plus or minus sign in front of it, I'm including that as part of it. Here's why. When I go to combine this 3x and the 5x, it's not necessarily clear whether I need to add or subtract them. If I take the sign in front of the 5x, and I think about just reading everything inside the box, 3x plus 5x, it automatically tells me what I'm supposed to do. 3x plus 5x would be 8x plus 2. I've now combined all my linear terms. This is a linear term, this is a linear term, and now I have a linear term and a constant term. Those are not like terms. One has a variable and one does not. So I can't combine them. So this is as simple as that gets. It won't get any simpler. We can do this again for another example. This one a little more complicated. First, I'm going to look for all my linear terms. I have a linear term there, and I have a linear term right there. And combine these linear terms and think about it as reading everything that I've put in the box. So it might be very helpful for you to actually draw those boxes around the problem. I've got negative 4x minus 2x. Remember to include the sign in front of the terms that you're combining. Now, I highly recommend as you do this, if you are uncertain at all, use your calculator. So if I'm doing negative 4 minus 2, it is probably best to go ahead and enter that into the calculator, no matter how sure you feel, and get that result. So we can see that negative 4x minus 2x would be negative 6x. We must include the x there as well. Now I can bring down my other terms. There are no more linear terms to combine this with, so I look for the constant terms. I have a positive 7 and a negative 3. So positive 7 minus 3 would be positive 4. So I would say negative 6x plus 4. And now this is simplified. That cannot get more simple. Remember, because it's an expression with a variable in it, I can never ever find what x is. I have to have an equation to be able to find x. Another example, now we have, notice, we have x's and y's. So we have two different types of linear terms. I'm going to look first at my y's. I look at it first because it came first in the equation, or in the expression. I might as well. I look for any other linear terms with y. That's a linear term, but with x. So it's not a like term, I can't combine it. Here's another, and that's it. So I can now combine these, 9y plus y, and this is understood to be 1y. So 9y plus 1y would be 10y. And everything else gets copied down. Remember, we show all our steps, we show all our work. Next, I want to look at the linear terms for x. I have a negative 2x and a plus 8x. And again, my recommendation to you, when dealing with these positive and negatives, no matter how much you trust yourself, it never hurts to put that in. Negative 2 plus 8 would be positive 6. So we say 10y plus 6x plus 6. There's no other constant term I can combine this with. And so we know now that this is simplified. So to recap, when I'm combining like terms, I'm simplifying an expression. I can't figure out what x and y are in an expression. I don't have an equal sign. But I can simplify and then combine them just like on here. I wouldn't say, if I was describing what is in this picture, there are 2 Twix bars, and then 3 Twix bars, and then 3 Twix bars. I would just put them all together. Same here. I wouldn't just say that there are 4 y's. There are y's right there as well, so I put them together. 4y plus 3y would be 7y. Copy down the rest of my problem. And then I look for all the linear terms in x. And I could put those together. Use a calculator if you're not sure, but negative 2 minus 1 would be negative 3x plus 2. And then I look for any constant terms. That's terms without variables. There are no constant terms to combine. So that, my friends, is simplified.